Welcome to the NYSERDA Commercial Lighting Business Partners Program Automatic Shutoff Controls webinar. Again, we'd like to thank the Lighting Research Center for helping prepare this webinar. I will be your presenter today. I am Ken Lotell of ICF International, and I'm managing the Commercial Lighting Business Partners Program for NYSERDA. And I've worked on the with ICF on this program for over 10 years, and I've been in the lighting industry for over 30 years. I have my lighting certification from the National Council on Quality for the Lighting Professions, also known as NCQLP, as do our account managers. And so welcome to today's presentation. We will be handing out the presentation afterward to those people who participated so you can actually submit for credits. So before we actually get into the presentation itself, what I like to do is start a poll to determine how many of you are viewing this webinar in your office together. So please take a minute and click on one of the choices here, 1, 2, 3, 4, 5 or more, and we'd like to capture that information. It's interesting that we have everybody register individually, but what we can't see is whether or not you're all sitting in one office taking the webinar together. So we'd like it if everybody could go ahead and vote. So we're getting there. We've got about 70% of the people who are on the webinar right now have voted. And we'll give it another second here. Anyone else want to put their vote in before we close the poll? Okay. Now, far and away, the majority of you are sitting in a room by yourself listening to this webinar. So we're going to hope to keep your interest and have this program continue. And I want to thank you for participating in the poll. So what we're going to talk about today are automatic shutoff controls. And you might ask why we're doing this when automatic shutoff controls have been used in the industry for well over 20 years. Well, the fact is that there's still the majority of the people that are out there are not using these controls. And so it makes sense that we still talk about this. A lot of the projects that come in under the Commercial Lighting Business Partners Program use them where they're required and then don't necessarily think about them beyond that. So we want to continue to push this and remind everybody that there's value in using automatic shutoff controls. So what kind of controls types are we going to be talking today about? Are things for the various types of shutoff sensors, the sensor positioning, performance specifications. We're going to go through these various different details. What some of the best practices are, so you can take these back to your design capabilities and add them to your projects. A good way to look at commissioning, and then we're going to provide you some application examples. So what are the types of automatic shutoff controls? There's time clocks, occupancy sensors, vacancy sensors, relay panels, and centralized controls. And we're going to break down each one of these separately. To make them all successful, you need to have them implemented correctly with wiring, installation, and commissioning. Time clocks, they actually turn on the lights on and off based on a preset schedule. You can actually program these. Many of us are familiar with the old analog type of time clocks where you changed the dial and you had little trippers, as they call them, that you would attach to the dial. But today, it probably makes just as much sense to go with an electronic time clock. The electronic time clocks will actually allow up to 32 various building zones and allow great scheduling and flexibility. What you want to be careful of, though, is that you don't create an overly complex situation where you have too many different zones and too much complexity in the design of the control scheme. You also want to be considerate of people that might need to use the office after the time clock offices or locations after the time clocks have shut off. So you want to have some kind of manual override within the space so they can flip the switch on for temporarily while they're in the space and get out. Let's say it's a cleaning crew at night. Somebody runs in, they left something in the office for the meeting next morning. You want to allow them to be able to turn the lights on for themselves when they're in the space. So time clocks are used to control spaces that have predictable occupancy. These might be areas such as offices and classrooms, libraries, retail spaces, etc. And so that you have these programmed so that they're going to go on and off at a particular time. Generally, the larger time clocks are installed somewhere near the lighting panel or the building control system. And you can do these in a retrofit format. They can be added after the fact. Now, a key function or a key item with installing time clocks is proper commissioning and programming. If you don't have the time settings set correctly, then it can actually throw off the whole process, and people are going to try and disable the time clocks. One good way to do this is use an astronomical time clock, which actually allows you to plug in the location of the building, and this will allow it to adjust based on the changes in the time, changes in sunrise and sunset during the day over the year. ASHRAE IES 90.1, the 2007 version, actually mandates using some form of time clock or automatic shutoff for buildings over 5,000 square feet. So some other types of controls are sensors. And they actually promote the use of lighting controls in general, and specifically sensors that turn off the lights when space is not occupied. These can either be vacancy sensors or occupancy sensors. For a long time, all we talked about was occupancy sensors, but vacancy sensors are actually very viable for most applications or many applications. So what's the difference? Well, vacancy sensors are designed to manually turn on the lights, but they still have an automatic off feature. So most of us have been taught since we were just high enough to reach the light switch to turn on a light switch. We know how to turn on a light switch. So a vacancy sensor allows you to turn on the light switch when it's needed when you walk into the space, and then it will automatically turn the lights off when you're not there, if you've forgotten to turn the lights off. An occupancy sensor is generally going to be automatic on and automatic off, and this usually can extend beyond just simple wall switches. Different types of motion sensors. There's 4 basic technologies that we work with. First one is passive infrared, which simply reads the heat motion within the space, and we'll show you actually how that breaks down and how it physically operates. There's ultrasonic, which sends out a signal into the space. Dual technology, which is generally a combination of passive infrared and ultrasonic. It could also be a combination of passive infrared and microphonic, which is the next one that we have on here. And what microphonic does is it actually picks up sound within the space and continues to trigger the device and tell the lights to stay on. Now, all these technologies are mature technologies. As I mentioned a couple of minutes ago, you may ask why, after this has all been around for more than 20 years, we're still talking about it. And it's simply because it still hasn't been used all that greatly or all that widely. But these are very mature technologies. They're tried and true. They're things that we can all use without being worried about things not functioning properly. There's excellent payback potential. We're actually going to go through some numbers later on in the presentation about how much energy you can anticipate to save on a rule of thumb. Now, we highly recommend that if you want to find out what the real numbers are, that you do a data logging process for each individual installation. But that's not always convenient or always cost-effective to do that. So we'll show you some numbers you can work with. And then motion sensors work well with when they're properly positioned or the type of technology is proper technology is selected for the space. So passive infrared actually has faceted lens. This is a ceiling mounted version, where it's also wall mounted versions. And the faceted lens allows for reading of heat motion in that space when the heat motion crosses the intersection of the various different facets. The various different lenses allow either for forward motion somebody to come towards the sensor, which isn't common with passive infrared. We'll talk about some of the specifics with that in a moment. Or most often it's for cross motion. You're walking across the sensor. And passive infrared, as I mentioned a minute ago, detects heat motion, but this is a direct line of sight type of device. It can't see around corners. So if you have an odd space, you have equipment in the way, you have all kinds of intersections in a hallway, you want to consider not necessarily using passive infrared because it can't see around corners. The movement has to be across the field of view, which is those segments that we showed a minute ago. Now, as I mentioned, these can either be a crossways motion across the sensor, which is the bulk of the devices for ceiling-mounted and wall-mounted sensors, but aisle sensors, which are designed specifically for warehouse storage-type aisle facilities, those are actually designed so that you can trigger motion by walking toward or away from the sensor. So you just have to make sure you know what kind of sensor you're working with. There are things that could potentially cause false triggering, such as people walking by an adjacent space that might be visible to the sensor. And we'll talk about under the commissioning section how you can avoid some of those problems. If a surface has sunlight, significant sunlight, or an HVAC outlet that's in a particular space can actually create some heat motion that might falsely trigger the sensor and leave the lights on. The next sensor we're going to talk about is ultrasonic. What ultrasonic actually does is it sends a Doppler wave out into the space and it bounces it off the objects in the space, and it learns what the typical or standard configuration of the room is actually going to be. So it's a constant pitch. So if a new object or an individual comes into that space, then the wave changes and it allows the occupancy sensor to trigger the lights to remain on. They're good at detecting movement pretty much in any part of the space. They can see around corners. They can see through obstructions. One of the places that we see ultrasonic used quite often, or maybe dual technology, is in washrooms, restrooms that have multiple stalls. That way you only have to have maybe one sensor in the space and it can cover the entire space despite the fact that there's a stall blocking the occupant from the sensor. So movement toward the sensor rather than across actually works really well with ultrasonic. What can cause false triggering with ultrasonic? People walking by in adjacent spaces that are within the sensor's range, so you have to make sure you've commissioned it properly to read the space that you're working with as opposed to outside the space. If there's an object that gets blown around in the space, then you might actually have some false triggering there. I had an instance years ago where there was a heat duct right outside the door of a lawyer's office, and it would, when somebody would walk by, it would push the heat into the space and it would move the paper on the desk, and that would actually falsely trigger the unit. So you have to be careful about those kind of applications. Dual technology, as I mentioned earlier, combines both passive infrared and ultrasonic. It also can be combined with passive infrared and microphonic, which we're going to talk about in a second. It's the most expensive of the products as far as the sensors, but it's very sensitive to motion so that you can actually operate it properly within the spaces that you need to. This is good for big wide open spaces like big open offices, and you want to make sure that you have it commissioned properly. We're going to talk about the commissioning process in a couple of minutes. Microphonic, as the name suggests, actually uses a microphone inside the sensor that hears the sound of somebody occupying the space. It's designed really as a secondary detection. As I mentioned, one of the other dual technology combinations is microphonic with passive infrared. You don't usually see microphonic by itself. So what would happen is the passive infrared would trigger the device to actually come on, and then a combination of the passive infrared with the microphonic detection would trigger the device to leave the lights on. And these are usually referred to as passive dual technology. The reason that they're called passive is they're not sending a signal out into the space. It's actually just passively listening to the sound in the space and triggering the motion or triggering the lights based on the sound within the space. Sensor positioning is actually kind of a critical issue here. You want to make sure that they're positioned properly and commissioned properly for whatever your application is. But there's a couple of options that you have. You have wall-mounted sensors, which is probably the most common. Take out an old single-pole toggle switch off the wall and replace it with a single-pole wall-mounted occupancy sensor, and most often they're going to be vacancy sensors. You can also use a ceiling-mounted version, as you can see in the middle picture here on the right-hand side. And then you can have corner-mounted sensors. These work really well in long hallways. They're mounted high on the wall, and they can aim the device down the hallway and see a lot of different spaces, different space areas, motion throughout the space. They can also be mounted or integrated into the luminaires. So I don't know if you've noticed lately, but you can see more and more options where the actual occupancy sensor is either mounted within or on the end of the luminaire. And this is really a good way to get that to the space without having to add additional wiring. So you want to make sure you're choosing the right sensor for the positioning that you need for your particular space. Coverage area. Every different sensor and every different sensor manufacturer has a somewhat different coverage area for their devices. So you want to make sure you look at the specifications for that particular device and understand what the coverage area is. And as we kind of looked at before, we looked at the passive infrared wedges, you can see that in a lot of cases, these sensors, especially with passive infrared, have wedges that they have for coverage area as shown on the charts here on the right-hand side. You want to make sure you match the coverage area to the size of the space that you're working with. So you may be able to use one wall-mounted sensor if the switch is positioned correctly in a classroom, if it's got the right size classroom, if it's a smaller classroom. Or you may need a couple of ceiling-mounted sensors to create the right kind of reading space or detection space. You may need more than one sensor based on the various different size spaces. So you want to take this all into consideration when you're specifying and installing your occupancy sensors. Performance specifications. Here are some of the things that you might want to consider, and this doesn't cover all the applications, but you might want to consider for your various different specifications. So for coverage area, if you're putting a specification together, you might want to require a minimum of 400 square feet read or detection for that particular sensor. Field of view. There are various different fields of view depending on the sensor, depending on the manufacturer. So you want to make sure that you capture the field of view appropriate for your particular space. So if you're talking ceiling mounted, you want to look at a 360-degree horizontal view or detection space and 180 degrees for vertical. So if you're walking underneath the device, it'll pick you up at 180 degrees from that. For wall-mounted, up to 180 degrees horizontal and up to 90 degrees vertical. You'll notice some of the sensors that are out there are actually 170 degrees, so they don't pick up the last 5 degrees on either edge of the sensor, on either end of the 180-degree wedge. You want to make sure in your specification that you require that the devices are not sensitive to extraneous signals such as radio frequencies, EMI, noise, vibration. We've seen some sensors over the years where they've picked up or interacted with sound from other devices, such as radios, so you need to be careful of those. It doesn't seem to be all that common anymore, but it's just something to be aware of. Failure mode. Especially with the wall-mounted switches, you want them to fail to the ceiling-mounted switches where you can't reach them very often. You want them to fail to the on position as long as the off remains operable. If you can turn the devices off, turn the switches off. Maximum timeout setting shouldn't be any longer than 30 minutes, and this is actually dictated as well by the ASHRAE codes or standards. And then this last item, you want to be careful to specify the standby power. You want to make sure that it's less than 1 watt. Many of these devices have electronics that are operating at all times, even when they're in the standby mode or if the lights are off. And this can actually create a vampire power situation where if you have enough devices in the building, you can add thousands of watts to the operation of the building by adding your occupancy sensors. In general, the savings you're going to garner from using occupancy sensors is going to far outweigh what you're going to lose from your vampire power, but you want to make sure that that standby power stays below 1 watt. Another group of performance specifications, you want to talk about what it can detect regardless of the location or orientation. So if you have a device that needs to see small body motion, you want to put that into your specification. So like typing the reading, that's good for a passive infrared wall-mounted switch. We'll see small body motion. Or medium body motion, reaching for the phone. You want to make sure you're specifying the motion that's appropriate for your particular space. Time delay, you need to be able to adjust the time delay. You want to make sure the demarcations are clearly marked. You actually will show you some pictures in a few minutes of what some of these devices actually look like, of how you actually change the time delay settings, and some of them are kind of hard to understand. And you want to make sure that these are calibrated within 10% of the set values. Minimum shouldn't be any smaller than 15 seconds. Again, with the commissioning process, you want to make sure you set your minimum appropriate to the type of activity in the space. And the maximum, again, shouldn't be any higher than 30 minutes, and this is set by the ASHRAE standards. You also want to have no user adjustments, especially with the wall-mounted occupancy sensors. NYSERDA does offer incentives for using or for implementing and installing wall-mounted occupancy sensors, but there's a stipulation that you cannot disable the automatic off feature. So you want to make sure that these user adjustments for time delay and automatic off are not something that are readily accessible to the general public. So what are some of the best practices that you want to check into as you're putting together your specification and trying to create an installation? So wall sensors still need to be able to give the occupants control over the lighting. You want to allow them to be able to turn on the lights, and if they just so desire, to be able to turn off the lights. I mean, if you think about a classroom or a conference room where they're having an audio-visual presentation, they want to be able to disable the lights, or at least to a certain extent, to be able to see the screen better. So this is something that you want to have control over in the space. You want to make sure you're eliminating false triggering caused by passersby to reduce sensitivity and reposition the sensor appropriately. We've actually also talked about some masking features that you might be able to do. We'll talk about that in a couple of moments. You want to keep the controlled luminaires in small groups. If you have one large open office area that has 50 different luminaires in it, you don't necessarily need to have all those fixtures coming on at the same time. So you can break that down into smaller zones that are more appropriate to the activity that's within the space. And a system should also have automatic on for public areas or manual on for private or semi-private areas. Automatic for public areas is so that there's no tampering with the devices. Generally, you want to get those up on the ceiling if you can. Some devices that are offered that are wall-mounted actually have tamper-proof features to them. So you just want to be aware of what you're ordering. Some other best practices that you can work with is place the occupancy sensors in areas where small movements are made. So a small private office, you want to be able to do a small switch there. You know, a replacement switch works really well in a small private office. And we'll go into some specific layout questions in a minute. You want to make sure that the manual switches are located within line of sight of the luminaires. Again, if you're dealing with passive infrared, they must be line of sight to operate properly. They need to be in intuitive locations. I've actually seen applications where, for whatever reason, the structure of the space or the layout of the space had changed, and now the hinge on the door had moved. And whatever happened, the doorway opens up and now blocks the device. So you want to be very careful not to put the devices behind a door. That's not an intuitive place to find it to flip the switches on, and it doesn't work if it's a passive infrared application. Switches should be clearly labeled, and you want to leave wiring diagrams and instructions for end users. If you have a more complex system with more details, you want to actually get in touch with the end user and probably have a training session, and maybe consider bringing in the manufacturer or a manufacturer's rep to come in and assist with that training process. So we've been talking about occupancy sensor commissioning and some of the things that you might run into. The commissioning allows you to adjust the sensitivity of the device, the amount, which is the amount of motion and what the coverage area is, and that you can also adjust the time delay. You can also change from automatic on versus manual on some devices. And again, this should not disable the automatic off feature of the device. If you have a device that allows you to disable the automatic off feature, this would not be a device that's incentivized under the NYSERDA programs. The adjustment of the devices come several different ways. You have potentiometers, which are little analog dials. You can see it over on the right-hand side. It actually says potentiometer. And this is what we were talking about before about demarcation. You can see there's hash marks there that show that you can turn the dial and make some kind of adjustment. But based on that particular device, you really don't know what the dial is actually doing. You just have to assume that it's somewhere in between the maximum and the minimum when you're switching through these various different levels of hash mark. Dip switches allow you to turn one switch on, one switch off, etc., in various different sequences to create various different adjustments in the device. And sometimes these are things that you're going to be doing over and over as you go through the process. So you want to make sure you're checking with your instructions. It may even help on the commissioning side to look at these as you're running your specification in the first place. What kind of details do you have to do, or commissioning process do you have to do with a particular device? Is it overly complicated? The graph on the bottom of this page on slide 21 shows you that the dip switches shows you the different configurations on and off to determine how many minutes or seconds the device will take to turn off. Some other ways to actually adjust for field of view. If you have a wall-mounted switch, a lot of times these are actually shipped with little masking devices, and essentially the masking devices are a little bit heavier grade of masking tape, colored masking tape, so it matches the color of the device. And it allows you to blank out the segments of the lens that would actually see out into a hallway. So you want to make sure you're covering that particular part of the commissioning so that you don't have false reading into the space. So next we're actually going to go through examples of various different types of installations that we can talk about for vacancy and occupancy sensors. Now, for those of you that are actively working on projects for the Commercial Lighting Business Partners program, please be aware that we require controls, vacancies, and occupancy sensors in some particular spaces. Private offices, break rooms, classrooms, conference rooms, training rooms, restrooms, and warehouses. For example, in warehouses, you don't necessarily need to have the occupancy sensors controlling every single luminaire in the space, but at the very least to control the majority of them. So if you have a small shipping area in there, maybe that doesn't want to be, you don't want to have that controlled with the sensors. But you need to have controls in those spaces to qualify those projects. So here's an application for a small private office. And you can see that the device is on the opposite side of the door from the hinges, putting it in a position where it's not blocked. It's in a good position to see the entire space. It's going to pick up small body movements. You can see this is actually a pretty small office. You can use passive infrared or ultrasonic in these particular spaces. Be sure that the door does not close up over the top of the sensor. And you also want to make sure that there aren't obstructions in the way like filing cabinets or credenzas. This application would probably be best with a manual on, automatic off type of device. Again, you don't want to disable the automatic off, but you don't need to necessarily have the lights come on automatically. Let's say somebody's coming in to drop a file folder or some mail on the owner's desk. You don't necessarily need to have the lights flip on every time somebody walks in to do that. You want to have to set the delay initially for 10 minutes. If that's not the activity correlation with that particular space, you may need to adjust that. Many times these are actually set somewhere at that 7 to 10 minutes from the manufacturer, but you want to make sure they're set there when you're actually commissioning the space. So how about a meeting room? It's a little bit bigger space. You've got different size meeting rooms. You could have a small meeting room, which might actually be less than 400 square feet, which would be more than adequate to just have a wall switch sensor in those type of spaces. Or you could have a large meeting room where you might actually have ceiling sensors or corner mounted sensors to actually view the whole entire space. You want to make sure that you have the right number of sensors for the space based on the coverage area of that particular device that you're working with. And then group luminaires by sensor coverage area. So you don't necessarily have to have all the luminaires on one individual sensor. Maybe you need to break it up based on the way the room is laid out. Another application is actually a break room. And here's a prime example of where you might not actually want to put the switch. If you can see where the top slide or the top photograph shows the switch is over by the door, but it's also kind of tucked away around the corner of the refrigerator. So depending on where the table is located in the space, or even if somebody's working for an extended period of time at the countertop preparing food, then that sensor would not necessarily sense them in the room if it's a passive infrared only. So you might consider passive infrared, but you might also consider dual technology for that particular application. For a larger room, just like the conference room or the meeting room, this is the same thing. You can either use ceiling mounted or corner mounted. And ultrasonic or dual technology would probably work well for these applications. So next we have a classroom application example. And here you can use either ultrasonic or dual technology as your primary technology for this particular space. You can work with ceiling mounted or corner mounted depending on the size of the classroom. Most classrooms require ceiling mounted based on the dimensions. And you want to consider integrating this with various different technologies or controls such as dimming or other photosensor controls. We're going to look at some more applications of that in a moment. You want to do this as manual on and automatic off, but you still want to allow for the teacher to have control to be able to turn the light switches off. Manual on because, as you can see, from many classrooms have glazing around the perimeter or skylights in the space, and this allows some light into the space. You may not necessarily need the lights on immediately when you come into the room. So classroom lighting systems have actually evolved just beyond just your standard occupancy sensors. And the Lighting Research Center actually did a few years ago a Delta case study or Delta snapshot on using an integrated classroom lighting system where all the components were all combined and did various different things. So it was using a direct and indirect lighting fixtures in most of these applications. There were whiteboard controls, occupancy sensors to control for occupancy sensor, but then the teacher also had a control center which allowed them to switch on and off the whiteboard and audio-visual mode. As we were talking about before, you may want to turn down or turn off the lights. And then you want to also have a general versus an audio-visual mode, so it's one or the other. You can't accidentally turn them both on at the same time. And then teachers also like to have a quiet time, especially for young elementary school students, a quiet time override switch where you can turn the lights down and give everybody time to relax a little bit and calm down from coming in from things like recess. In this particular application, there wasn't a daylighting controller here, but they found in various different demonstration case studies that about 38% of the energy reduction, there was a 38% energy reduction across 7 demo sites and 28 classrooms, and several of them were actually here in the capital region. If you have an interest in seeing some of these systems in action, we can get you in touch with the locations, and so you can go take a look at them. We found that K through 12 generally preferred to have manual switching 80% of the time and then 20% by the sensor, as opposed to universities which were 50% manual switching and 50% sensor. We're going to talk about ownership, whether it's an owned or a shared space, in a minute in relation to energy savings. And this kind of fits into that, a K through 12 type of space. One teacher may be in that classroom all day long, and so that you would have a different type of control schematic or control operation than you would in a university where you might have various different professors rotating in and out of the various different classrooms. This particular study showed that there was a very high level of teacher acceptance. They really liked to be able to control the whiteboard task light. It was very helpful. They wanted to be able to darken the front end of the room, especially when they were doing slide presentations. And then the quiet time, especially for the elementary school and middle school students, worked really well. As I mentioned, some of the areas were done here. They were done some middle school locally, and they actually liked, the instructors really liked it. The downside here with the universities is that the instructors who are coming and going, some of them may be part-time, some of them may be adjunct professors, wouldn't necessarily be trained in how to actually operate the system, and so there was a little bit lower acceptance in those particular applications. If you want to see more information about this particular case study, you can go to the Lighting Research Center website and actually download this. So restroom application, we kind of mentioned before about using ultrasonic in the multi-stall type of restrooms like you see down on the bottom. For a single stall, one person use type of applications, you could use just a wall-mounted switch, but this is one place where you have to be really careful about the type of device you use. I would hate to be caught in the restroom with the lights going off because I'm inside the stall and things weren't commissioned properly. So you want to make sure you've done this correctly. Set the time delay based on usage. If it's a very active space, you might actually want to set the time delay out a little bit farther to avoid problems with overly frequent switching. So if you have people coming and going fairly frequently, setting it out at 15 minutes might actually allow the lights not to turn on and off too frequently. Obviously, if it works too frequently, it might actually reduce the life of the lamps in the ballast. Hallways, public access areas, passive infrareds work really well for corner mount solution or long throw if these are long, narrow hallways. If you've got large intersections, you can work with passive infrared to be able to easily mask off the area so you're not getting any false triggering. And then with ultrasonic, it could be a good solution, but you want to be careful about where it's located in relation to adjacent spaces. Sensitivity adjustments are going to be needed during the commissioning process to make sure everything works properly. So then we also have warehouse applications where you have a ceiling mounted sensor or a fixture mounted sensor, integral mounted sensor, and it depends on the way the warehouse is laid out. This particular photograph shows you large areas of pallets that may or may not be there at any given time, as opposed to a racking system that's a pretty permanent situation. So in this case, it's probably a good idea to have every single fixture has a sensor on it, so that when the pallets get high enough over a particular fixture, they don't have to stay on, they go off until those are opened up again. And passive infrared actually works really well in these type of spaces. It gives you can get various different shaped devices as far as the patterns go, so that they can read along narrow throws or they can read rounded throws. And then lastly, you want to have an automatic on, automatic off device. Most of these devices are going to be in locations where nobody can actually reach them, so you don't want anybody to have the need to reach up and turn the devices on or off. It should happen automatically. So the Lighting Research Center, again, did another case study, or Delta case study, specifically about warehouse applications and controls. And in this particular application, they were replacing metal halide fixtures with T5 fluorescent high bays. And the illuminances actually went up about 3 times higher than the original lighting, with about 23% fewer watts. The workers were actually pretty enthusiastic about the change in the light levels. And then there was some additional energy savings. The fluorescent allowed the control of a 2/3 output versus full output. So you could have a high, low, medium kind of light level setup within the program of the device or the controls. Rewire the ballast appropriately depending on what you need. The occupancy sensors were actually mounted individually on the various different, you can actually see this up at the top picture. They're mounted on each individual luminaire, and this worked really well. And then they also used wireless systems as well, which makes it easy from a wiring standpoint. You don't have to do a lot of extra wiring or circuiting or reconfiguration. So if you want to read more about this particular application of sensor case study in a warehouse, you can go to the Lighting Research Center website and download the actual case study. So we've been talking about what the various different sensors can do and how much energy you can save. And as I mentioned, probably the best way to determine what occupancy sensors will do for a particular space is to do a data logging process and actually check to see how occupied or unoccupied a particular space is. But if you're not able to do that based on cost or convenience, then you can use some rule of thumb that the areas are going to save energy in various levels depending on the size and the shape and the occupancy of the space. So a large workroom or an office, and this might be this would be shared office space, can actually have a 55% reduction in energy. A restroom can be about a 50% reduction, a file room 45%, and then small offices would have about a 22% reduction in energy. The California Energy Commission estimates typical energy savings range anywhere between 35 and 45%. In warehouse applications, the warehouse application we were looking at before might actually save up to 75% energy. We've actually seen studies in grocery store chain warehousing where they picked their busiest aisle in a 24-hour-a-day operation and found that it was only occupied about 25% of the time. And they thought it was occupied all the time. So if the lights were off or at least turned down, then they could save that much more energy. NYSERDA uses a conservative estimate of about 30% energy savings across the board. So in summary, there's some things that you need to consider when you're doing this and you're working occupancy sensors. You want to select the most appropriate control for that particular application. Is it going to be a passive infrared? Is it going to be a dual technology or an ultrasonic type of device? What makes sense for that particular space? You want to look at the specifications or even go so far as to look at the instruction sheets of the various different sensors that you're going to choose to determine what the coverage area is. You want to make sure you're picking the sensor that's appropriate for that particular space. Position the sensor where it can best detect the motion. You want to make sure it's not behind obstructions. You want to make sure it's not in a position where it can get false triggering from some other motion outside the space. And then you want to make sure you're conditioning the sensor for the actual space occupancy patterns. So if it's a really active space, you might actually, believe it or not, want to extend the timeout feature so that there's a little bit more overlap and the lights aren't triggering too often. So with that, we've gone through the presentation. If you have any questions about the various different details in this program beyond today's questions, you can reach out to one of our account managers somewhere across the state, or you can go on to our commercial lighting program website at nyserda.ny.gov/CLP, or you can email us at clp@icfi.com. And with that, we're going to look online here and see if we have any questions. We don't have any questions online today. And so with that, I'm going to go ahead and open up the phone lines.
Would you like your guests to be able to unmute their own lines by pressing *6? If yes, press 1. If no, press 2. All guests have been muted. You will now rejoin the meeting. guests have been unmuted. You will now rejoin the meeting.
So we now have unmuted all the lines, so I'll open it up to any questions on the phone. Does anybody have any questions? Okay, we did have a question come in on the online process, and we're being asked if everybody will get a copy of this particular presentation. And yes, we will be sending this out to everybody who attended, as well as sending out a quiz so that you can actually return the quiz to receive either AIA certification or credits for CEU credits for this particular presentation. Are there any other questions on the phone?
So if your client decides that they do not want to put an occupancy sensor in, does that mean that they will not qualify for rebates at all?
The end user will still be able to qualify for incentives if the commercial lighting program application for our business partners would not qualify if there's not an occupancy sensor in one of those required spaces. But that said, I would certainly work closely with the end user if it's a matter of putting in 1 or 2 occupancy sensors. You know, at the minimum, they're going to be saving like a 30% reduction in energy for those particular spaces. It's worth it. But the end user would not be disqualified if they don't put the occupancy sensor in.
Okay, thank you.
You're welcome. Have a message or a request on the online. I'm trying to. So somebody's asking about recent control systems that also implement employee ID cards when swiped that turn on certain sets of lights. That's a possibility. That can certainly be part of larger energy management systems. It's not something that we talk about in this particular presentation, but it's definitely something that's viable if you want to do that. It's also, unfortunately, not something that is readily incentivized under the various different NYSERDA programs, but it is certainly an option. Somebody else also asked, is this along the lines of DALI control systems? The wireless systems might have that involved, but in general, the occupancy sensors that we're talking about don't usually get into DALI specifics. What's the cost difference between a less expensive relay panel versus a traditional time clock? You know, I don't have exact prices in my hands, but my understanding is an astronomical time clock with 8 to 30 zones, something like that, might be in a couple $100 range. And then most of the control panels, the panels themselves probably start at about $1,000. So depending on what you have to control, it might get expensive quickly. The key thing is to keep it as simple as possible. The more complexity it is, the harder it is to make sure everything is controlled properly. So maybe all you need is a time clock for that particular application. Somebody else asked if this can be applied to roadway lighting. We are seeing more and more occupancy sensors being used with roadway and exterior lighting. I don't know that I'd actually use it on street lighting per se, but I have seen applications where people have added this to parking lots and parking lot lighting. The caution here is that if you're adding this to HID fixtures, you don't want to turn the fixtures off completely. You need to have some kind of a dimming ballast or bi-level or step dimming ballast so that the lights do not go off completely. Otherwise, you're going to have that 15-minute cool down and warm-up period before the lights come back on. LEDs and fluorescent and still things like halogen, if those are around, and even I believe induction lighting don't have those warm-up and cool down and warm-up periods that you have to be worried about. And I think that's all the questions we have on the phone or on the written questions. Are there any online questions on the phone? Okay. Well, we appreciate everybody taking the time to join us today. And if you have any questions, if we overlooked a question that was on the online system, on the webinar system, please by all means get in touch with us, and look forward to receiving those emails with the presentation and the quiz within the next day or so that you can go ahead and get your credits in. And with that, thank you everybody. Have a good day.